Hey everybody, welcome back. Heat up your soldering irons because we're going to build this kit. I decided to make this video so you could watch me assemble the Mr. Eggs macro keyer while you build along at your own bench. Now, if you're not actually building the keyer, you might find this video is pretty long and detailed. Instead, I recommend you look on my channel and watch the high-speed version. You can see the entire process done. The video clips have been edited and sped up to where the whole thing is done in 5 minutes. But if you're going to build one, let's get started. Before we start putting our Mr. Eggs Smart Macro Keyer together, let's take a look at the parts that come in the kit. Of course, there's a PCB board right here, double-sided, everything's labeled. We've got a little block of ICs, it's got a voltage regulator on it, crystal, transistor, sockets for the ICs. We've got the LCD panel here. That'll be our display. We've got a packet of miscellaneous parts here. There's some jacks in here, audio jacks. There's some potentiometers in there, header pins, connectors, wires, a couple potentiometers in there. We've got a little packet here of resistors and capacitors and diodes. And we have a little packet of hardware. And the hardware's in here because the LCD panel and the PCB are exactly the same size, and they're going to fit together like this in a little sandwich, and that hardware is going to be what we use to hold them together. So there's the parts. Let's start building. In addition to all the parts that we just looked at, when you open your box, you're also going to find that we have a parts list here. And there's two things I'd like you to notice about this. The first is that it's called a parts list in order of assembly. The second thing is I want you to notice that there are two columns of check boxes here. The first column is already checked. That's because before we mail any of these kits out to anyone, we double check that all of the parts are there. That's how you know that you're going to get a complete kit. As you assemble your kit, we recommend that you check off the second set of boxes to keep track of where you're going. I also would like to draw your attention to this green surface. It's not just about making a nice video. It really has a specific purpose. This is a foam sheet of craft material. You can get them at any of the hobby stores. I actually got mine at a local Dollar Tree store. They're not expensive, but it's like craft paper, but it's really kind of a foamy substance. And I like working on that because as I flip my PCB over to put parts on one side and then turn it to solder on the other side, the actual parts themselves press into this foam and it helps hold everything right in place while I'm soldering. It's also why we've listed the parts in this particular order. They're in the order according to the height of the component or the thickness. And if you put a tall one in early, then the shorter ones have a tendency to want to drop down through the printed circuit board while you're soldering. The first thing I like to do with the printed circuit boards is clean them up. I use just some ordinary rubbing alcohol, put it on a little cotton ball, and then I just give the surface of the printed circuit board a good wipe. Just kind of clean that up a bit. Do that on both sides. Make sure that you're using isopropyl alcohol. You want to make sure that the alcohol doesn't remove the white silkscreen ink. Maybe you want to test it in one corner first. Now a lot of people say, well, is that really necessary? And with these boards right here, in this particular kit, It may not be all that important. In the past, though, I've been using printed circuit boards that I get from an outfit in Portland, Oregon called Park, and those are excellent printed circuit boards. All the places that you solder are gold plated, but gold oxidizes so easily that you want to clean it off a little bit. What I've noticed is that I would be soldering and I would get a little ball of solder on one of the pads, and it would just be a ball, and it didn't want to stick to the pad because of the oxidation. The material here doesn't oxidize as easily as the gold does, and I don't seem to see that problem as often, but I still like to clean the board before I start. We're going to start by installing the resistors. Most of the resistors, these have the lowest profile of any of the other parts. So I'm going to take these resistors and capacitors out of the bag here and kind of lay them out, have them ready to go. We've got some LEDs here, these electrolytic capacitors. You can tell by the size of them, we're not going to be installing those for a while. It's these little tiny things that are going to go in first. These capacitors over there, some more capacitors there. Well, here's a diode. Just move these capacitors out of the way. More resistors. And I know just by looking that the tiniest things are going to go first, and that is these 4 resistors right here. And sure enough, right here on the assembly sheet, it shows me that we have 4 470 ohm resistors. And then over here we have a description. And in the description of the resistors, you will see that each line, or almost each line anyway, has a red word on it. And that red word is a clue to help you identify which parts you're going to pick up. The key word here is tiny. There will be 4 resistors, R2, 3, R4, and 5. They are yellow, violet, brown, but they're real tiny. We've got them right here. Of course, you can use your multimeter and put them on there to confirm that those are the correct resistance. R2 and R3, R4 and R5 are located right here. What we have here is a current limiting resistor which will drive one of these LEDs. In fact, we have one for each of the LEDs. Over here, we're going to have another set of current limiting resistors right here so that you can hook up your LEDs to pins there. R2 and R4 are redundant, and R3 and R5 are redundant. I'll bend them, and I'll just insert them in the holes right there. With resistors, there is no polarity. I just put them in, and I'll just kind of spit those out a little bit. And there's the last one. Now notice how when I turn this over, I can press this down and those resistors will actually sink a little bit into this foam pad that I'm working on. So we'll just speed things up with the camera. I'll solder those in, we'll clip them off, and then we'll go on to the next step. There we have it. Those 4 are soldered. We'll double check this side of the board. Everything looks good. We'll clip those off. Now, when you clip off leads, hold on to the loose end. Don't let them fly. I wear glasses. If you don't wear glasses, I recommend that you wear safety glasses, but certainly hold on to these leads especially if anybody's around watching you work. There we go. So that's the first 4 resistors. I'm going to check this off. Oh, I guess I should check off up here also that I cleaned the PCB. Next, we're going to install 4 resistors. They are 1 K ohm resistors, that's 1000 ohms, are 1, 7, 8, and 11, and these are all tan. They'll be easy to spot because they're all together, kind of taped together on these tabs. Our 1K resistors are all installed. Things are moving along pretty good. I'll check off now that we've done those 4 resistors. Our next resistor is a 150 ohm resistor. It's going to go at R6, and it tells us here that it's a brown, green, black, black, brown resistor. We only have one of them, and there's a few others that we are only singles as well. We need to be sure that we get the right one, but it shows us here that the key word is to look for a green band on this 150 ohm resistor. So let's see what we have here. Looking for a band that's green when these colors are not that easy to spot. You can use a magnifying glass and see pretty well. That might help. But we can also take our volt ohm meter and we'll just double check that we've got the right one. I think that's got a green band on it. I'll dial this in and let's see what we get. Right in the range there, 149. This meter, I don't know if you can see it that well in the video. So we've got the right one. This is going to be R6. So let's see, R6 on the board is right there by R4 and 5. Put it down there, flip it over, press it into our pad, and we'll solder that guy in. Check. Like what we see. Put that off. And we'll check off that step. Now we need a 10 ohm resistor. We're going to look for a gold band on that. There's also one with a yellow band. So we want to be sure that we don't confuse those two resistors. That one is definitely yellow and that one is definitely gold. That's our 10 ohm resistor, and the 10 ohm resistor is R12. So we will find it right down here and put it in. Again, there is no polarity on resistors, so it doesn't matter which lead goes in which hole. Okay. Very good. Now we need a resistor that is a 1 meg ohm resistor. This one has the yellow band. We compared the yellow with the gold just a minute ago. We should be able to find it right here. And this one, the directions tell us, will be R13, so it's right there next to R12. We will stick it in. And solder that one. Finally, we have two resistors left over, and here they are, right there. Those should be our 10K ohm resistors that go into R9 and R10. We'll find those right there. When we're done with these, we will have installed all of these resistors. That one there, this one right next to it. Okay, our resistors are in the board. Let's check that off and see what's next. So we have a slot key diode that we're going to put in the board. It goes at D1. Diodes have polarity. We have to make sure that we put them in the right way. So what I want you to notice is you look for a band on the diode. And there's kind of a gray stripe at one end. And when you look at our printed circuit board here, you'll see where D1 is right here. There is also a line on the silk screen. And you want to be sure that the line on the diode matches up with the line on the silk screen. Also, to indicate that there's polarity, one of the pads is a circle and one of the pads is a square. So when you see square pads, that generally means pay attention to how you're putting them in. So that'll go in there just like we did with our resistors, and we'll solder it in. The purpose of the diode is kind of just a safety protection thing. It's for polarity protection. If you're hooking up, say, a 9-volt battery to this project, and you accidentally reverse the contacts and touch your battery backwards into the connector, this diode will protect the rest of the circuit from that reverse polarity. Current can only flow through the diode one direction. So if you hook it up right, it just flows right through the diode. If you hook it up wrong, no current flows through the diode and everything else is safe. There's a minor drawback to this, and that is the diode also drops the voltage. So by using a slot key diode, we reduce the amount of voltage drop to where it's not significant. But it does drop the voltage. So if we hook 9 volts into this circuit, we're not going to get 9 volts to our voltage regulator. It'll be slightly less. If the diode wasn't there and we just shorted across there, everything would work fine. We just have to be careful how we hook it up the battery would drive the circuit longer. So it's a trade-off. We'll check off our diode right there. And the next two items that we're going to install will be our red and our blue LEDs. And we're going to do something a little different with the LEDs. You'll see when you look at the board that they're listed on the back side. The silk screen is on the back side for these two items, and it tells us right here where to put the blue one and where to put the red one. These diodes, like the slot key diode, do have a polarity to them, and it's important that we put them in the correct way. You will notice that one lead is longer than the other, and that will help you. You'll also notice that the pads, there's a round one and a square one. And as I said before, when you see a square pad, that usually indicates that it matters which way you put that component in. So what we do is we put the long lead into the square pad and the short lead into the round pad. Now, the diode doesn't really sit on the board. We need it to sit above the edge of the board. So we're going to pull it out just slightly and bend it over so that it looks like it's going off the edge of the board. We'll do the same thing with the red one. Long lead goes into the square pad. I'll put them in on the back side of the board where the silk screen is, and we'll bend it over so that it sticks above the edge of the board. I'm going to turn this back this way and lay it down, and take a little bit of time at this point to make sure that I'm happy where the diodes sit, because they're going to light up. Your friends are going to see them, so take some time and get them straight and make them look nice. And then we'll solder them. And this time I'm soldering on the front side of the board. There we go. Hopefully you're seeing that well. We're losing some of the natural light. We might have to add some extra light here in the ham shack, but those look good. I'll go ahead and clip off those leads. And that's our red and our blue LED. Next, we're going to install a crystal. You will find the crystal attached to this little foam block of parts where the ICs are. It's this silver guy right here. Looks like a funny little hat maybe, and it'll go on our board right here where it says XTAL for crystal. There is no polarity on this component. It doesn't matter which way you put it. However, there is writing on it, and so when I see writing on something, I like to put it in so the writing's right side up, not upside down when I'm looking at the board. It has makes no difference electronically. It's just about the aesthetics. It's about making your project look nice. Get some solder in there. Looks good there. I'll clip those leads, and we will check the crystal off on our list. Now, let's start installing the capacitors. The first set is going to be easy because there's actually 5 of them. See, 1, 2, 4, 7, and 9. They're all 0.1 microfarad capacitors. They're very tiny. If you look at them through a magnifying glass, you'll see that they're marked with 104 on the side. They'll be easy for you to spot, though, because they are the only ones you have where there's 5 of them on there. Okay, so there's 5 of these guys. Looking at my notes, I need to find C1. It's way up here in this corner. I'll just stick that guy in there. Now we're looking for C2. I had 2 in there. C2 is right over here. C4, there's 4 right here. C7 is next. And then the last one is C9, way down here. So we've got all of those guys there. Push this down. Now, because we put the smaller components in first, we can still press those down a little bit. We'll start soldering those to speed up the video while we do this. Very good. We'll get our checklist out and mark off that we have installed those 5 capacitors. Now, 2 more capacitors. These are 22 picofarad capacitors. They will have a small 22J on the side. They are these 2 little guys right there with the real long leads. And let's see, they're going to go in at C5 and C6. They're part of our crystal circuit. So they're going to go there. That one there. That one there. We will pull solder on there. And that takes care of those capacitors. We have 2 more capacitors, but they're fairly tall, so we will be installing them sometime later. But next, we're going to put in a little miniature push button. We're going to find that in another bag. There are 2 push buttons in the kit, but they're not identical. So let's see if we can get this guy to come out. We got it stuck to a phone jack there. Just set that there for now. And then there's one other switch in here. It's longer, and we won't be installing it right away. So you see that there's a difference there. This is going to go on the edge like those guys do later. But this shorter one is our reset switch, and it is going to plug in here. Now, there are 4 legs on this this component, but it's not a square. So make sure that you line them up so that they go in there, and it'll just kind of click into place when you get them in. And the whole part just sort of snaps into the PCB and snaps into the printed circuit board, and then we can just solder that in. This will be our reset switch right there. We will check that off. Now we're going to put our IC sockets in. There's a 28-pin IC socket and an 8-pin IC socket. They are also located on this little foam board. We'll pull those out. And let's talk about these. When you look at the PCB and you look at all of the pads for the IC socket, you'll see that one of them is square. And here we have another set, and one of them is square. That's indicating to us that there's a right way and a wrong way to put these in. Now, these are just the sockets, so if you inadvertently put the socket in backwards, it won't matter. You'll still be able to put the IC in the correct way. But the IC socket has a little dimple, a little notch on one end. You can see it right here, and it's perfectly smooth at the other end. When you look at the silk screen, you'll see a gap at one end and not the other. And that little dimple matches up with the gap in the IC socket. And that's where we'll put it in there. We'll hold on to it as it goes around, and then if you kind of grab the pins with your finger here, you can set it down on your pad so that it stays put there. Now there's 28 pins that have to be soldered here, and you want to get it right, because if you don't get it right, you're not going to change it. So what you want to do is go down and simply solder one pin. I happen to be doing the pin that's at the corner there that's square. It doesn't matter, but you probably want to do one of the corner pins, and then just flip it over and kind of see that you have it the way you want it. You can move it a little bit, but more importantly, is it flat against the printed circuit board? And this looks really good because I'm able to push down on that foam. Now, as a precaution again, I'm going to solder just one pin on the opposite corner. After we get two corners soldered, we can double check it one last time. And now we have 26 more pins to solder. We'll zip up the film and just race right through that. I like to look at the pins and make sure that I'm happy with all of those solder connections there. And this looks pretty good. Now we'll get ready to do the other socket. Just as with the 28 pin, there is a notch on the little 8-pin socket right there. And when we look at the silk screen on the PCB, there's a gap there. We're going to match those together, line them up. Drop this guy in place, flip it over. We'll do the same thing we did before with the big one. I'll solder one corner, check it, make sure it's down the way I want it to be. Solder another corner clear on the opposite side. One more check, notch is where I want it. Okay. We will finish the job. Okay, that takes care of the 28-pin socket and the 8-pin socket. Now the next step is to install the last of those disc capacitors. This is 1,000 picofarad capacitor. There's 2 of them. They will have the numbers 102 on them. We'll take a look at them here. And see if you can see it, but there's a 102 on there. There is no polarity on these. They're going to go into C3 and C8. C3 is right here, and C8 is down here by it. I'm going to go ahead and clip those leads, and then I'm going to touch up that solder one more time. Just looks a little gloppy there. Much better. Much better. I can trim it better too. Okay. So that takes care of all those capacitors now. Now, we're going to install these audio jacks. One of them came out of the bag early. There's one for the headphones, right here. They have actually 5 pins, and they'll go in there like that. And then another one will come over here, which is for the receiver audio. We will set that down. The center pin here is ground. It's the one that's sort of in the middle, separated from others. It may take a little longer to solder these because they're bigger terminals there than, say, the leads that we've been soldering with resistors and capacitors. So you heat it up and then apply the solder, and then there we go. Solder only one. I like to do the center one, then give it a look, see how you like it. Everything looks good. Now there's 4 more that are soldered along there. There we go. We need another one of those. Here he is here, and it goes on this side, just as we did before. And we've provided this little connector right here to hook the voltage into your keyer. You'll be able to run this on anywhere from 9 to 15 volts. And we have a little JST connector. It's got a jack with a red and black wire attached to it that you can run over to whatever you're going to use as your power supply. There's lots of options that you can consider for that. This is going to plug into the board right here, and it'll get soldered there. And you just want to be sure that the red lead is going to go where the plus sign is. So what I just did there is backwards. And you have to watch out for these things. I have purchased them from China, and they're not consistent about where they put the red and where they put the black lead. So you want to be sure that you're lining the socket up the correct way so that it's going to match there. Now, it's easy enough to change these things if you do want to switch them, but let's make sure that we have it lined up the right way, and then we'll solder it in. It's for the one I've got here, it shows a notch in the silk screen, but that's wrong for our setup. So I've matched it up. Now I've removed the wire. We'll put this back in there and flip it over, and then we'll solder that guy right in. But check your polarity. There is a plus sign on the printed circuit, and you want to be sure that that's going to line up with the red lead on the wire connector. We'll just set this aside for now. We don't need the wire on there as we put in the rest of the components. Okay, I've marked that one off. So now we are going to install two 10K potentiometers, R17 and R18. And so these are like little tiny volume controls. There's one there, there's another there. They have like 3 terminals on them, and they're gonna go in down here in this area. One of them, this is R14, controls the contrast on our LCD display. And then the other one is going to control the volume. We're bringing audio in from your radio. We have audio coming from our microcontroller, and you also have audio from your keyer itself. And this second potentiometer, it adjusts the volume from our microcontroller chip, which is quite a strong signal, so we really need to attenuate it, or it comes out a lot louder than everything else you're listening to. So we'll put those in. You'll notice that one of the pads is square, but it turns out that because of the shape, you cannot put it in wrong. It'll only go one way. Okay, those guys are in. The next steps in the project are very interesting ones. It has to do with these header pins that you have here. You have a strip here of 24 header pins. We have another set over here of 16 that are put together as a male and a female. And the directions tell us that we're going to take the 24 pin male header and break it apart into smaller groups, and they're all going to come out of this right here. So start by breaking off 6 pins from this strip here. So go 1, 2, 3, 4, 5, 6. Break that off, and we need 2 of those, so I'll do another 6 here. 3, 6. We have those 2 set there ready to go. We'll get the rest of them out of this piece. So I'm going to set that in there like this. I'm going to flip this over. And now I would like my pins to stand up straight. So I can do that by rocking my board, or actually sliding the board back and forth, and I see the pins rocking in there. And I just move them until they're coming out perpendicular. So if the pin is coming out perpendicular on the bottom side of the board, it should be perpendicular on the top side of the board. I'll solder just one of the center pins here. and then we'll check it to see if it's down flat, it's perpendicular. I might move it just a little bit to one side. I can do that by remelting the solder here, sliding it over there. That looks really good. Now I can solder the rest of those pins. And the other 6 are going to go right beside them. They're going to go right in here. But I want to show you a little trick. I'm going to take this male header out of the female header. Kind of a tight fit. And it broke as it came out, but that is not a problem. And then I'm going to use the female header. Now remember, one of these is soldered and one of these is not. I'll just put the female header across here. That lines everything up and kind of secures it. And we are ready to solder the second set of 6. And that little jig that we put on the other side holds them right where we want it. There we go. We've got the first set done. Now, this is an interesting set of pins because they're very handy. What I've done is brought all of the things to this one edge of the board that you might ever want to set up externally on your project. So if you're going to put your keyer in a case, there's a place here to either bring in or take out 5 volts. You can hook up LEDs here. You can hook a speaker up here. You can create a new function switch, or you can bring audio in through the auxiliary part from your receiver there. So all of those pins really represent other places on the board in a convenient spot for you to get at them as you customize your own work. Now we need to set up 2 triple pins. 3 pins here, break that off, and 3 pins again. And the 3 pin headers go, one will go over here. This is just an alternate way of hooking up paddles to your keyer. There will be a nice terminal here that you can use, but there is a second way to hook up paddles, and that will be there. And then the other set will come over here, and it works more or less like a switch. We're going to have a little jumper that goes across that, and it has to do with what kind of a plug are you plugging in for your headphones. I'll solder those in and we'll continue. Nice. I'll put this one in here. It's a little tight fit in there. Set it down. Rock the board, slide the board, rock the pins. Get them perpendicular. Solder the center one. Check it out. I like it flat against the board. Looks good. Okay, next we need a group of 4. So we have 6 left here. We're going to need a 4 and a 2, and we'll break those apart. The 4 goes way down here. Now don't be confused with these holes over here. There are not going to be headers on those. They're there for future customizing that you might want to do. If you choose to change the software in the keyer, you have access to the pins just as if it was an Arduino. But this one is important, and it will go right there. Among other things, it has the ground and the reset. So if you're going to put an external button on for reset, you'll hook it up here. But it also has RX and TX. And the four of these are all convenient if you want to play around with the software. You can reprogram the microchip using an Arduino just by bringing jumper wires from your Arduino over to these pins. So they're really convenient for that. I'll put that in. Of course, if you think you're never going to change the software, you don't even need to put this header in there, but might as well, so that it'll be ready for the future. I'll do the same thing. I'm going to solder one of the center pins, and I'll make sure that I think I have it perpendicular. Looks good on the front. We'll do the other one. That's 2, 3, 4. Now that leaves us with 2 pins left over, and they're going to be similar to what we did with the paddles. This is an alternate way of hooking up to the transmitter, to key the transmitter. So we'll have a big terminal in here where you can screw wires in and tighten them down, but this will do exactly the same thing as those two will do. And this will be convenient if you are, maybe you have a QRP transmitter that you might want to use, and you just want a simple way of hooking up to that transmitter so that you could key it. We have an alternate way of keying our transmitter. Okay, that takes care of those headers. I'm going to put the jumper on over here because I know I'm going to be using stereo headphones, so I put it on the S side. Now this little guy over here that broke when I didn't intend for it, it's no problem. We'll just put it back together like this with the second half right down there, and it's good to go, no problem. Next we're going to install the transistor. This is a 2N222 transistor. This is the switch that is going to key your transmitter, and it has 3 leads on it, and you want to take and pay close attention to the silk screen. You will see that there is a flat side on the silk screen and a curved side on the silk screen, and when you look at the the transistor, you'll see there's a flat side there and a curved side there. So obviously this is going to go in there so that the curve matches the curve. Now you're going to find that the spacing on these leads is tighter than the holes on the printed circuit board. So what you want to do is simply bend these out a little bit so that you get the correct spacing. That might take a little trial and error, but you can work on it, and once you get it in, you can push that down. The transistor will probably not go all the way to the bottom of your printed circuit board. It doesn't have to. Just put it in. I do like to get fussy with it and make it look nice, but there it is. I will now solder that in. I think I'll do the center one first. Okay, I'll just take one last look at it, see if there's any twisting I want to do, make it look tidy, make it look nice. Has nothing to do with the function, but if you're going to go to the trouble of building a kit, you want to show it to people, it might as well look nice. There, our switching transistor is installed. We'll just clip those guys off. And we'll check that off the list. Next, we have two sets of screw terminals that we're going to install. One of them has 3 terminals. That one will be hooked up to your paddles, and the other has only 2, and that will go to the key input on your transmitter. This connects to the transmitter, this connects to the paddles, and these are going to go right in here. You want to give some thought to which way you put it. The wires that come in to your board will come in to these connections here. So you want to be sure that those are on the outside of the board, not the inside. You don't want to try to put wires in from here. But we'll put those down. They're fairly large terminals, so it's going to take a little more heat to solder them correctly. I'm going to get it good and warm first, and I'm going to solder, as I usually do, just the center one. Good connection there. Double check it. Is it straight? Am I happy? And I'll solder the rest. Like I say, it takes longer because there's more metal there to heat up. Okay, that looks good. Now, the other one on the other side, where it says X-mitter, transmitter, again, make sure that the connections for your wires are facing on the outside of the board, not the inside. Okay, coming along. So we have the 3 contact terminal and the 2 contact terminal installed. Now we have 3 electrolytic capacitors that we could put on. C12 says here it was a red one, and we can find C12 on our board right here. You'll see there's a minus sign there, but there's also a square pad and a round pad. And what we've learned is that when you see square pads, then we're talking about something that requires proper polarity. Your electrolytic capacitors are marked with a stripe on one side. This is your negative side. It's also the shortest lead. And usually your circuit board will show you where the negative one is. You'll see the minus side there. These almost always go straight to ground on those. But also there's the square pad, and as we've done with other components on here, the long lead goes in the square pad, and the short lead, which is the minus side, goes in the round pad, and that also will line up our stripe on the electrolytic capacitor with the minus sign. So you have 2 ways to be sure that your polarity is correct, and we'll be able to solder that in right there. We'll clip those leads off. Now we have 2 more electrolytic capacitors, these little blue ones. They're going to be part of our power supply circuit. We'll have a voltage regulator that's going to go in here, and then these electrolytic capacitors will filter anything coming in and through there. Again, we have a long lead and a short lead. We have a stripe that's indicated minus. We have a square pad and a round pad with a minus sign showing us. So again, the long lead goes into the square pad. The short one goes by the minus. Just press it in place. The other one, the same thing. Notice they're the opposite though, but long lead in the square pad, short lead where the minus is. Now we'll turn that over, and they're a little wiggly in there, and I'm going to solder one side of each capacitor right now. That gives me a chance to look at it, move them around, trim them up. I'd like to see them nice and straight. Has nothing to do with the function of the circuit at all. It is simply the aesthetics. Make your project look good. I learned that from my father. My father was a plumber. All his work was sealed up into the walls of buildings. But before that building was sealed up, every pipe was straight, everything looked good. He was very fussy about that. And I had a great deal of admiration for him. I think of him when I do stuff like this and try to make it straight. So that takes care of all the electrolytic capacitors. I'll mark those off on our list. And now we have our 5-volt regulator. That's this interesting device here. It's plugged into the pad. We'll pull it out, and it's going to go in here, and you're going to see there's a square pad and 2 round pads. So guess what? Polarity counts. Oh boy, does it. The silk screen will show you a double line right here, and that double line coincides with the heat sink that's on the back side of the voltage regulator. So when you push this in here, you want to be sure that the heat sink is on the side where the capacitors are. Don't get it in backwards. And it's when you put it in also, it won't go all the way to the bottom. And that's a good thing, because this thing gets hot, and that allows it to get some air circulation around it there. So we'll set this in here. I think I'll solder the middle one first. It takes a little more heat. That's ground. The middle one is ground. Now my part is a little crooked, so I just bend it back a little bit. In fact, you're going to find this thing flops around all the time. You're going to constantly be straightening that thing. And so you can see the pins now don't all line up with each other, but it won't matter after I clip them off. So we'll solder this one in here. So what this part does is it accepts any DC voltage between, say 7 volts and 15 volts on the input, and it makes sure that the output voltage is always 5 volts. And what it does is it takes all the extra voltage and turns it into heat. So if you run this board with 12 volts, it has more voltage to unload in the form of heat. This will get hotter than it would be if you ran it on 9 volts, but it can easily handle either of those. So I'll get trim these off right there. And now the next component is our switch. This is our function switch. I found these online because I wanted a switch that could stand up tall above the edge of the board and I got them and I like them, and then I discovered a cool thing about them that I didn't know I was going to get, and that is you can even push it sideways, any direction, and it makes contact for you, in down or to any direction, which makes it real easy to use. This switch needs to be mounted on the back side of the board. It goes here in this little area that's been marked off FNC. The function switch goes right in there. Two of these leads are the actual connection, and two of them are simply to hold it there and give it some strength. So I'm going to position it here. We have to solder it on the front of the board, and so I'm going to go in here. It's a little tight in this area, but you can do it, and I'm going to solder one of those connectors. I'm going to take a look at it, see if it's put down where I want it. I'm happy with that. Now I will solder the other three. Two of them are for the circuit, and two of them are simply structural. They hold the switch in place, and they allow us to push on it. Now, before we install any more components, it's time to do a few checks to make sure that what we've done so far is going to work right. On the second page of instructions, there's a list of things that we should do. First one is to make sure that there's no continuity between 5 volts and ground. What we want to do is make sure that there's no shorts in the board, which could be caused by, say, a solder bridge or something. We'll use a multimeter for this. I'm going to set my meter in this one position here where it allows me to check continuity. We don't need to look at the dial for this at all. You simply touch the two probes together and you should hear it ring. And that tells us that we have continuity. What we want to do is make sure that there is no ring. So I'm going to go here where it says 5 volts and put one probe there, and then on the other side here all of these pins are connected together. They're all ground, and I'll put that there, and there is no pin. See, if I put it here, you hear the ping, and right there, no ping. That tells me we don't have a short between 5 volts and ground. That's important. We can check that off of our list. Now it says to go ahead and apply a voltage to this thing. So I have rigged up a little 9-volt battery here. I've soldered it over to one of our connectors, and this connector is going to go right in there. But it just so happens that the connector that I have here, the polarity is reversed. So that's no problem. I have different wires for different projects. I'm simply going to take this little and I could put it back on the opposite direction, but because I'm just testing this, I will go ahead and just slip it on those pins. I've got the red going there on the right side. It goes in there just like that. So red's by the plus sign. Okay, so we'll put our voltmeter in here, and I'll switch it over to volts DC, and I'll bring the probes in. We've got our 9-volt battery sitting right there. All of these pins are ground, so I'll just grab some there. I'm going to reach over, grab 5 volts there, and look at that, 5.02 volts DC. That's great. Our voltage regulator right here is doing a job. Just to show you what's going on, I'll take our battery here and I'll put the probes on it, and you can see that our input voltage is 8.7 volts. So we're taking the 8.7 volts and running it through our voltage regulator and getting the 5 volts that we want. You should find some spare jumper wires in the kit. We're going to use some of these for the next little test that we're going to do. We'll just take this one cable here that has male connectors on one end and female connectors on the other, and we only need to use one side of it, so I'll just take the green side here. I'm going to put it on 5 volts there, and what we'll do is we're going to see if we can light up these LEDs, and we do that by touching them here to let's see, we're going to touch them to, what do the directions say, A4 and A3. So if I touch this to A4, the red light lights up. I'm touching it. You can see it light up pretty good there. That's good. And if we go over here, the blue one should light up. And you can see that it does. So that's just a little test that we can do. I'll mark that off a list that that works. And so it looks like we are ready to remove our voltage and remove these jumper wires. The next thing is going to be installing our LCD panel. This LCD panel is going to go right in here, and we're going to need a little bit of hardware to do that. So got a little package of it here. We'll dump that out, and we'll proceed. The directions tell us that we are going to use these black screws that are here, and we'll put them through the LCD panel, and then take one of these standoffs and twist it on the other side of that screw. And you can do this with your fingers, and we're going to do that to all 4 corners. So there we go. We can set that down. That's ready to go. Next, we are going to take 4 nylon washers and put them on each of these posts. Next, we're going to put the 2 boards together with our connector between them. And let's give some thought to this. There's really no reason electronically why it makes a difference which way you put it, but for future use and future projects, I recommend that you put the male pins on the LCD panel and the female header on our Mr. Egg's board. And the reason for that is that if you ever want to do another project, you can take the panel off and it will have male pins attached to it. And those pins can even be plugged into a breadboard. So if you're experimenting with a project, maybe you're doing something with an Arduino, you'll be able to do that. So how can you tell which is which? Well, I can tell by looking, but the female side is much wider. The male side is very thin in there because it's plugged inside. Now, remember, mine was separated, so you see I can pull it apart. There's the male. It plugs into the female. You want them connected together at this point, and we'll just set that right there on our panel, just like so. It's ready to go. And now we're going to take the board we've been working on, and it sits on top, and you line everything up. You got lots of things to move around to get into place. I've got one standoff over here that wants, there we go, I got it down. And we've created this sandwich now with our circuit board and the LCD panel, and we have this in between there. Now, just so that things don't come apart while we're working on it, I'm going to add a couple standoffs here and here just temporarily. So with those temporarily put together, we can start soldering. And we'll do the same thing to the other side. It's kind of rocking around here. I think what I'd like to do is balance it off if I can. It's very easy to do. Kind of standing up on that guy. Now looking at those, I want to take a close look at them and see how well we did. I think I've got one there I'd like to touch up a little bit. There we go. So I guess we're ready now to put in some ICs and give this a try. Well, let's put our chips in now, our little ICs. The little guy right here, this is a little audio amplifier. And we're going to plug it in there. On these ICs, you're going to find a little dimple there. And it's just like we did on the sockets. There's one there and there isn't one there. And that matches up with the dimple and the notch on the socket. And so everything lines up there. Just plug that guy in. And then this is our Mega chip. It's already programmed with the Mr. Ag's software on it. It also has a dimple and even a dot on it. They go on this side here next to the voltage regulator. That'll go in there just like that. If the pins don't seem to want to fit, all you have to do is set this down on your table and rock it a little bit to bend them in. Take your time. It may take a couple tries to get them in there. Make sure that it lines up so that none are sticking out one end. There we go. The whole thing is in. It's ready to go. I think we're ready to put our battery on again, and let's see what's going on. So again, I'm using my little doctored set. You know, I even have a note on here that says to check the polarity. I think it's because this is the one that's always backwards. But we want to be sure that the red lead is going to go to the plus side of this connector here. Put it on, and then don't be surprised when you do this to see that there isn't anything on your screen. It's just bright light. That's because we have to adjust the contrast, which is on this R14 potentiometer on the back. And you can just grab a hold of it with your fingers and start twisting it. And if you go back and forth, you should be able to see some text appear. There we go. Just like that. We have Mr. Ag's up and running. Now, when you first power it up, nothing has been configured, so it goes immediately to configuration mode, and there will be some instructions then that you need to follow after that. You'll find those on our website, and I'll have a video that you can look at. But we do know that it's working. We see the text on there. One thing that you can do is press the reset button, and you should see the blue LED light and then go off. Now, if that happens and you don't see anything on the display, you know that the microcontroller is working. It's functioning correctly. You're going to need to look for a problem in the display itself. Remember, there are 32 solder connections here. It's real easy to get one of them that's bad, and you might have to go through, look at them with a magnifying glass, touch them up, and once they're all correct, you should see text on your display. Adjust the contrast, because it's real easy for it to be completely gone, and you find just the right spot and go too far, or then just back off a little bit and set it up that's comfortable for you. I'd like to just take a little diversionary side trip here and show you a real slick trick in case you're ever into a jam and you need to do this. It's not something that we need to do at this point in time with our keyer, but let's say that something's wrong and you didn't put this chip in correctly. Maybe you have it reversed. By the way, reversing this chip will do no harm to it. It's really clever the way they engineered it. The plus 5 volts and the ground pins are in the exact middle of this chip, and they are on both sides on the exact middle, but reversed like a cross. And so if you have accidentally put this chip in backwards, you are not going to harm it. All you have to do is remove the power, remove the chip, put it back in the correct way, and everything is almost always going to be just fine. But let's say you need to remove this chip for whatever reason. There's 28 pins in there. How do you get it out? Well, let me show you a real easy way to do that. This is a handy tool that you can get at Harbor Freight. They're designed for working with springs and clips in automobiles. There's another version. This is a soldering tool. Both of them have this scribe, or this point on them. And all you need to do is bring that point in underneath the chip, between the IC and the socket. Now, I deliberately laid out the circuit board so that a tool could be brought in there. It'll fit in just above the reset switch and allow you to get between those two parts, the socket and the IC. And then all you have to do is gently rock and push that pointer between the two, and the chip will come off. You can do the same thing with the LM386. You just go in and it pops right off. Very easy to remove an IC from its socket, even though it has 28 pins. We'll put ours back on, just like that. You probably noticed that we still have some hardware sitting here, and you might wonder, okay, what's with that? Well, it has to do with creating a nice little stand to hold our keyer up so that it's at a slight angle, which makes it easy to read if you have it down low on a table. And if you want it flat, you'll be able to do that easily as well. So what we're going to do, first of all, is remove the bottom 2 screws from our display. We put those in. They're just kind of temporary. Just take those screws out there. Now, on the back side, we're going to remove these 2 extra standoffs that we put back here to temporarily hold the board down while we were soldering. So we'll take that one off of there and that one off of there. So we've removed screws from the bottom. We've removed the standoffs from the back side at the top. Now, instead of the standoffs, we have 2 little black nuts. And we'll just put those on. You don't need to use any tools with this. It's not going to go anywhere. Just put them on finger tight. They'll be fine. That takes care of that. Now on the front, where we've removed those screws, we'll put in those 2 standoffs that we took off the back. So we've got those there. And now we have two small ring connectors. And what we'll do with those is we'll just take our screw, put it through the ring connector, and screw it down a little bit snug. And we'll put the other one on the other side. Now, that provides like 2 little feet on the front, and when we set it down, you get a bit of an angle. So it'd be like that. We'll get a different camera angle on this for you, but it sets it up so that you have a nice little stand there. There is a protective film that's on the LCD panel that you can simply peel off, and you have a nice thing there. If that screw flops around a little bit, and we can put our power on here and see how this all works. If I match up my polarity, there we are. Well, this concludes the construction of our Mr. Rags macro keyer. In the next video, we'll talk about how to hook up our paddles, a speaker, how to hook it up to the transmitter, and we'll talk about the initial setup and programming the keyer so that you'll be able to use it on the air. Thank you.
And hey, don't forget to subscribe, like, and share.